This video is a supplement to what I do in lecture, showing a quick sort of review and preview of how I do ray tracing for lenses. As with mirrors, ray tracing is a graphical alternative to using the thin lens equation. It has the advantage that it illustrates how images form and the difference between real and virtual images. But as with mirrors, you have to follow very specific rules if the result's going to be equivalent to what you get from the equations, which were derived for a thin lens. Once again, I've drawn the pictures on top of the ones from the textbook, so sometimes they're a little bit busy. However, in this case, because the textbook diagrams are close to being drawn correctly, there aren't too many sort of conflicts between what I'm doing and what they do. However, the big problem here is they omit what I call the secondary ray, so you only have two rays and no third ray that allows you to check your results. For a converging lens, where the focal length is positive, the textbook shows just these two rays parallel to focus and the central ray, omitting the secondary ray. And this is kind of confusing because they show two focal points, the primary one on the right and the secondary one on the left, but they never use the secondary one. The secondary focal length point on the left, which is the same focal length from the lens as the focal point on the right, is the secondary focus that's used to construct the secondary ray. This is the ray that you get if you put a light bulb at the secondary focal point, and a light bulb there will produce diverging rays that will produce a parallel beam after they go through the lens. Anyway, we always start with the central ray. It's the easiest to draw, same for any lens. It's a little bit different from the mirror in that the line goes through the actual center of the lens. Highlighted here in yellow, the central ray is constructed by connecting a point at the top of the object to a point at the actual physical center of the lens on that line that runs down the physical center of the lens, and drawing a single line through there. I show two arrows here, the ray arrow that comes from the object and the arrow that continues on through the lens. It's the arrow going through the lens with the arrow head on the end that tells us where the photons go. Ray 1 is the primary ray. It does what parallel light does. Parallel light goes through the lens and hits the focal point. It's brought from parallel to focus. So we start with a parallel line as we do with the mirror, but now it goes through the lens to the focal point. It is bent at the midplane of the lens, at this point highlighted in yellow, at that green sort of center line. The thin lens approximation corresponds to making the entire lens of sort of zero thickness, so it's all at the spot where that green line is. So anyway, a primary ray comes in parallel to the axis. You have to draw that carefully. Then when it gets to the center line of the lens, it is bent through the primary focus. This ray 1 is the same as the textbook ray 1. Secondary ray, ray 2, which is not in our textbook, is focused to parallel. It starts at the secondary focus and comes out parallel. So this line is constructed using the object and the secondary focal point. And then it comes out from the midplane of the lens. So here I've hacked a picture from the textbook to show how that works. Light that comes from the secondary focus, the one on the object side, when it hits the lens, it comes out parallel. I've shown an object here in green, so you can see that you lay your straight edge from the secondary focus to the object until it hits the the lens, and then from the lens it comes out parallel. The dotted line from the secondary focus to the object is there really just to guide the eye. When you draw this, you want to have your straight edge all the way across like that, but only draw the light that starts at the object going to the lens and then coming through the lens and out parallel. That way the solid line shows you where light actually goes, and you'd use a different dashed line to trace that secondary ray back as needed. Summarize, if I've got a standard sort of converging lens real image, parallel ray is the one that's shown in the book. I've highlighted that in orange, the central ray in blue, and then the sort of dark red color there going through the secondary focal point and coming out parallel to the axis. And you see all three rays cross at the same point, which is the point where the real image forms. For a diverging lens, focal length is negative. We'll always get virtual images. The textbook again has only the two rays, the parallel unfocused ray, where the primary unfocused point is on the virtual side, on the side where the object is, but no secondary ray. The secondary array uses that other focal point on the right, the secondary unfocused point. Notice that which one you use is reversed from the converging lens case. Where the primary focus was is now where the secondary unfocus is located, and vice versa. Here the light goes towards the unfocus, and as it is unfocused, it comes out parallel. And I show here the traceback thick dashed line that goes back to where the virtual image forms. Okay, so now the ray construction. The central ray, ray 0, the first one I always draw, just connects the object and the center of the lens as before. Nothing different here. Notice again, though, we're using that point at the center of the lens. Primary ray is parallel and then away from the unfocal point. So we start by drawing our parallel ray till we get to the midpoint of the lens, but then we have to have it bent away from the unfocal point, which is on the left side, on the virtual side of the lens. So see the yellow highlighted point, which is constructed from that parallel ray, usually just by measuring the object and carrying that height over to the lens. And then we use that point and the primary unfocal point to construct a ray. That light goes out at the angle shown there, and the dashed line is the construction, the sort of virtual construction of where our brain thinks that that diverging ray 1 came from. The secondary ray uses the unfocal point to get to the lens and then comes out parallel. We connect the object and the secondary focal point, the secondary unfocal point really, until we get to the midplane of the lens, and then we come out parallel to the axis. So again here I'm using the dotted line to show the construction where my straight edge will go. I don't ever draw that when I'm really doing this for real. So the light goes from the object toward the secondary unfocus, where that dotted line would go, but it never goes there. It hits the lens. When it gets to that point on the lens, it then comes out parallel, and the traceback dashed line shows where our brain thinks that that ray 2 came from. I'll pause here for a little bit so you can look at this, because this is not in the textbook. Goes towards the unfocal point, hits the lens, comes out parallel. In summary, an example like one we have in the textbook, the parallel ray is unfocused. The central ray goes right straight on through, not actually through the center of the lens in this case. I've followed the line that's in the textbook for this particular example. And the secondary ray goes towards that second unfocus on the right. You can remember which one to use because the diverging lens with a negative focal length produces virtual images. Its primary unfocal point is on the virtual side of the lens. So negative focal length goes with having the unfocal point on the negative side of the lens. The auxiliary one, the secondary one, is on the other side, in this case on the real side of the lens. Okay, so there's a couple of examples in the book. I've updated them just to show how these rays work. So the first is sort of a standard real image case. The secondary ray uses that secondary focus on the left. So you can see where the primary ray is there, parallel to focus, and this is the focus to parallel ray that I've added to the picture. Notice it does a nice job of confirming that you do have the image in the right spot, and like with mirrors, the secondary ray sets the height of the image, therefore it sets the magnification of the image. It's quite useful because of that. In this case, it just confirms what you got from the central ray and the primary ray. For easy cases, that'll always be the situation. However, the secondary ray is necessary to get the correct height, and this is particularly the case when you've got a magnified image, where there's, particularly when there's a large factor like in this example here, where there's a very large and virtual upright image. Notice that the parallel and central rays, parallel to focus and central rays, cross each other at a relatively shallow angle. That makes it difficult to get an accurate location of the image. Whereas this secondary ray, which comes from the secondary focus to the mirror, to the lens, and then out parallel, it traces back, gives you the height of the enlarged image, and has an excellent sort of angle with the other two in terms of giving you the intersection point where the image forms. In this case, notice you have to extend that center line of the lens upward to get the point where this ray sort of goes through the lens. This is a geometrical construction. The rays don't have to actually go through the lens itself when you're doing the construction. They just show where the ray would go if the lens was big enough for that light to go through the lens. Okay, so as before, these pictures are taken from our textbook. In many cases, they've been modified to make them work better for our purposes here.